Hi everybody, and welcome to Unit 6. Unit 6, we are studying what is known as stoichiometry. Stoichiometry is the study of amounts of substances in a chemical reaction. And this is actually my favorite unit of the entire year. We are going to be using things that we have learned from our previous units. Writing formulas, balancing equations, using factor label, all of it comes together in stoichiometry. All right. When we write a balanced chemical equation, it actually represents the number of particles that react and the number that are produced. That's, remember, why we have to balance it and make sure that we are conserving mass the way we're supposed to. Here's the big, and it is in bold in your notes for a reason, so big stars by this. A balanced chemical equation gives us a mole ratio for each of the components in the reaction. All right, and we know once we're at the mole, that gives us power to talk about what mass, all right, your either reactants or products will be. So let's see this in action. All right, all stoichiometry problems, every single stoichiometry problem that you're going to do will always start with a balanced equation. Always, always. Sometimes I give you that equation, sometimes you have to do the equation. But please remember that the reaction must start with a balanced reaction. So here we go, in your example in your notes. Write the reaction for the synthesis of ammonia. Well, we are making ammonia. All right, and ammonia comes from nitrogen and hydrogen. We're gonna remember that both of those are diatomic. Okay, then I know I'm gonna have to deal with my hydrogens right away. So I have a 3 there. I'm going to put a 2 because least common multiple is 6. I'm going to put a 3, and now we are good to go. All right, so now let's talk about our new part. All right, what mass of ammonia is formed when 250 grams of hydrogen reacts with excess nitrogen? This word excess, you're going to see in a lot of the problems we do at first. Excess means that you have plenty of that substance. It won't run out. So basically, it means you don't have to worry about it for that particular problem. All right, so as always with any of these problems, you want to ask yourself, what am I looking for? Well, you're looking for the mass of ammonia. So over here, I like to write what my final answer is going to be. Grams of NH3 is formed when 250 grams of hydrogen. So 250 grams, hydrogen is H2. All right, so we're at an amount of hydrogen. We need to go to that amount of ammonia. All right. In order to go from one substance to another substance, we must have a mole-to-mole ratio. So I need to change from my grams of hydrogen into moles of hydrogen. 1 mole of H2. I look on my periodic table, all right? And as with all molar masses, you find them from the masses on the periodic table. And I know that the mass of H2 is 2.0 grams. Always have a tenths place for your molar masses. All right, here's the new step. Here is your mole-to-mole ratio. You want to get rid of moles of H2, so they're going to go on the bottom, so they divide out. You want to go to moles of what you're looking for, which is NH3. All right, great. Well, where am I going to get these numbers from? I'm going to get them from this balanced equation. All right, in front of H2, I have a 3. In front of NH3, I have a 2. For every 3 moles of hydrogen that react, you get 2 moles of ammonia. This is your mole to mole. All right, really important. Great. So if I were to stop here, I'd have moles of ammonia, but I asked for mass, so it's going to take me one more step. In 1 mole of NH3, the molar mass is 17.0 grams. All right. Okay, I'm then going to plug this into my calculator. All right, so I have 250 times 2 times 17 divided by 2 times 3. All right, because remember, I'm going to multiply everything in the numerator, divide it by the product of the denominator, and it gives you 1,416.66, and it keeps going on. But remember, I have 2 significant figures here, so I should really round this to be about 1,400 grams of ammonia as my final answer. All right, great. Okay, why don't you stop now, pause the video, and go on ahead and give the next practice a try. All right, great. So let's go on ahead and take a look at this. How many moles of glucose are needed to completely react with 250, a little hard to read on my printout, grams of oxygen? Well, you should remember from biology, glucose is C6H12O6. You're reacting that with O2. All right. This is a combustion reaction. It's going to give you CO2 plus H2O. All right. Don't panic. Glucose would be the only large hydrocarbon I would expect you to know the name of because you dealt with it so much in biology. You're going to go through and balance this, and when you do balance, you're going to find that your coefficients are actually 1, 6, 6, and 6. Okay? So, again, always remember, always start with your balanced equation, and we have it there. How many moles of glucose are needed to completely react with 250 grams of oxygen? So what are you looking for? You're looking for moles of glucose, so moles of C6H12O6. You're starting with 250 grams of O2. All right, I'm going to change those to moles. 1 mole of O2. I'm going to look at my periodic table, all right, and that has a mass of 32.0 grams because O2 is 2 oxygen, 16 plus 16. Here we go with my mole to mole ratio. Okay, I want to get rid of oxygen, so it goes on the bottom. I want to go to glucose, so it goes on the top. All right, I'm going to look at my balanced equation. I have a 6 in front of that O2. I have a 1 in front of the glucose. All right. I punch that in my calculator, so it's 250 times 1 times 1. So 250 divided by the product of 32 times 6, and that should give you 1.3 moles. All right. Okay, so one last one for you to try. Again, feel free to pause the video. All right. Assume that the decomposition of potassium chlorate, 80.5 grams of oxygen is formed. How many grams of potassium chloride, the other product, would be formed? So this is an example of a decomposition where it's not just going to its elements, but I'm telling you what its products are. So we're going to start out, potassium chlorate is KClO3. All right. And we know, assume the decomposition, 80.5 grams of oxygen is formed. How many grams of potassium chloride? So this goes to potassium chloride and O2. All right, when I balance this, again, I'm looking at my oxygens because they're going to cause me some problems there. So I'm going to go a 3 and a 2 and a 2, and I'm balanced. Okay. What am I looking for? I want to know how many grams of KCl. So my final answer is going to be grams of potassium chloride. I'm starting with 80.5 grams of oxygen. So 80.5 grams of O2. All right, going to change those to moles. 1 mole of O2, as we saw in the previous example, is 32 grams. I'm now going to use my mole to mole ratio. All right, so moles of O2 on the bottom. Moles of what I'm looking for, all right, which is KCl on the top. It is absolutely fine that both the amount you're starting with and the amount you're ending with are both products. In stoichiometry, it does not matter. We can go back and forth, products, reactants. That doesn't make a difference as long as we have that balanced equation. So I have 3 moles of oxygen, again, coefficient, 2 moles of KCl. Final step, I need to go moles of KCl I want to get rid of, grams of KCl. All right, in 1 mole, I'm going to check my periodic table, and it's 74.6 grams. All right, multiply everything on the top, divide it by the product of the bottom, and you get about 125 grams of potassium chloride. All right, well, welcome to stoichiometry, and we're going to be doing some more practice with this in class. Have a great day, everybody.